All right, so now we're going to talk about boot processes, and this is one of those areas where I wish I could spend a lot more time. The reality is that we could easily spend several weeks working on boot processes, getting a system up and running, optimizing it, and making it work, and I genuinely believe that that's critically important. Unfortunately, because we're trying to create this as an online class, I didn't want to throw anybody under the bus, if you will. If you weren't able to get a hold of a machine that you could build Linux on, having you build a Linux machine would be something you wouldn't be able to accomplish anyway. So I've made the decision in this course to really focus on all the other processes associated with managing and maintaining Linux, as opposed to that sometimes chore of effectively installing Linux. That said, if you want to install your own Linux machine, I would definitely suggest it. Ubuntu is easier to install than Windows. So, give it a shot and play with it. I would suggest, if you plan to have any real involvement with Linux in the future, that you definitely work through these slides again and apply them to installing your own Linux box. And maybe try a couple of different ways to install and break and fix and break and fix to get through it. But for this class, I'm just going to kind of wander through these slides and kind of approach them more as a definition thing. So with that said, let's hop over here and just pop the slides up. So there are significant objectives associated with the Linux Plus test, associated particularly with understanding the boot process and the Grub2 bootloader. I'm going to give you some of the general stuff, but you definitely want to read deeper into that and probably want to at least build a machine or two yourself before actually going for the exam. So when you're booting up a machine, it's important that you understand what's really happening with that boot. Right? All systems boot up. That's what boot systems do, right? But it varies from system to system. Most systems at least follow these same steps. And I'm looking at my slides and realizing you're getting the wrong slides here. Hang on a second. Let's fix that. And where are the slides I'm actually talking about? I know I have them. I'm looking right at them on my machine. There we go. All right. That's a little bit better. Let's see if we can't fit this a little bit better for you here. Pull that over. There we go. All right, so I'm sure this makes a lot more sense now. Let's take a quick step back. Here are your objectives. The boot process, configuring the bootloader. It's important that I kind of look at my monitor from time to time to see what it's showing me, right? So when you boot a computer, you're loading an operating system to make it available for users. That's what booting means. So typically the device powers on. That hopefully is an obvious step. And then the BIOS loads. I tend to still call it BIOS because I'm old, but it really isn't. It's the UEFI, which is, I can't remember. Universal. I can't remember it. I'll remember it and I'll blurt it out halfway through. But the UEFI is what tests your hardware, identifies the bootloader that's actually going to load the OS, right? So it's this little chip that sits on the motherboard. It's been flashed with a certain amount of memory that will stay until usually until the battery dies or it's destroyed in some way. And it says, oh, you want to restart your computer, you want to start this OS by default or that OS by default. You also see this if you dual boot. You see this message where it says, oh, I want to show this Linux or that Linux. Once it decides what to load, it starts loading, right? It reaches out and it loads the kernel, that core process for the operating system. Once the kernel's loaded, then the kernel can then call all of the other processes that have to occur. And there are lots of ways to boot, other ways to book. That really should be boot. Lots of ways to boot. You might boot from a CD-ROM or an ISO file. You might PXE boot. You might actually boot from a network. There are lots of ways to boot, but generally speaking, we're talking about booting from a hard drive on the same machine. This is really important. The reason I'm talking about this as opposed to doing stuff is because you do not want to play with your bootloaders in the cyber range. Feel free to play with your own, but do not play with the bootloaders in the range. If you get in, you go in there and you start messing with grub files and things like that, it's bad. Please don't do it. You're going to break it. Best case scenario, I go in and reset it. You lose anything you've done. Worst case scenario, I have to get tech support to go in and fix it, and then they yell at me. So don't mess with your bootloaders unless they are on your own machines. So, master boot record. This first sector of a drive that I'm kind of wagging my head because that's not always true anymore. But it loads a partition table and a bootloader that tells the system where to go next. The problem is that different systems treat that a little bit differently. So, for instance, Windows was famous for destroying the master boot record when you would create it. So, if you tried to dual boot Windows and Linux and you had Linux on it first, Windows liked nothing more than destroy Linux's bootloader before it would install. And so there are some challenges associated with that that you can flip through. There's lots of documentation online to kind of walk you through the different ways to deal with things. It's not so bad anymore as long as you're paying attention. They do tend to sit in the FI system partition now, which is a little bit better than being in that MBR. The great thing about that is that once it's in FE, every OS has its own totally separate bootloader. There's no concern with it writing to the first sector and then Windows coming along and writing to the first sector right behind it. Next thing we want to talk a little bit about is grub. So you're going to hear this word grub when talking about Linux. Usually we're actually talking about grub 2. But grub is the bootloader that is most typically used in Linux systems. All right, it handles the boot process for the operating system. So the firmware reads the bootloader, and then the bootloader loads the OS. I need to drink 4 or 5 more cups of coffee. I can't speak this morning. And starts it all up. So that's what grub is. Grub 2 is the boot process handler for Linux. So grub has been around forever. The original grub worked on BIOS, not the FE chip that's there now. So as we moved to FE, we had to move to grub 2. But some of the things that you'll notice about the grub system is it would recognize drives and name them as HD1, HD2, HDO, which is a little different from the way I've been showing you, which is this newer grub 2 system, the dev SDAs, SDAs. Again, it's not a perfect one-to-one correlation, but that's typical. So grub 2 brought in new features. If you have a legacy system that's running the original grub, you actually can install grub 2. Just make a backup first, and then you can bring it in. Now I've given you the GNU manual for grub, which is going to go into a lot more detail than I'm certainly going to go into today. Again, I just want you to be familiar with the words. But if you want to get into it, I would strongly recommend you read it. Again, it is good information to have if you're using your own machine, and it's certainly critical information if you're building Linux machines. We're just going to kind of do some hand waving at it for this class. All right, so just a couple other things to be aware about, and again, I may come up with some clever way to show you this sort of thing, but I don't have a clever way to do it right now. But in the grub 2 boot menu, you get to edit what it says. So for instance, if I were to go to the grub D, and this really is the number 40_custom, is the name of the file, and in most systems you'll notice it's got nothing in it unless you've edited it. But that 40 system, or that 40 custom, is actually a user messaging file. So if you've ever dual booted, you know that often you'll see a message like, what operating system do you want to start? So this would be where you would go in and you could actually customize the file to say, hey idiot, you're supposed to run Linux, but if you really want to run Windows, you can click number 2. Maybe I'm the only one who says that. And then if you want to deal with other things like what it looks like, if you want to make it use the graphical environment instead of a text environment and those kinds of things, you can go to the default grub file. So default grub, and you can actually edit those things. There actually is a grub2 graphical menu. I don't know why you'd use it, but there is one. And on to something a little bit more concrete. So boot process logs, and you actually can look at your boot process logs in the cyber range. You won't hurt anything. Look at these. So if you do the do less, you'll see all the processes. Let me see if I can pop back over here and take a look at my cyber range here. And here we go. So if I were to say, and I have cats in the background that are banging on each other, I apologize. For instance, ID, MESG, and I'm going to pipe this to less so we can actually read it. And you can see what's going on, right? It's initializing the CPU, and there's the boot image, there's the kernel support. You can see there's a lot of really cool stuff going on. You can see that it sees the Zen hypervisor that's already installed in my version of the cyber range. You should have that too. You got all the stuff associated with Zen. A lot of stuff about what's going on in memory. As you can see, there's a lot of information associated with your operating system that is being logged. I'm still clicking down through this stuff. Isn't that crazy? And I only know like 5% of what this stuff means. But if I was going to be making changes, I would certainly know where I was making. For instance, we'll talk about AppArmor a bit in this class. I would certainly know what to go look for and Q to get out of that, and would have a pretty good idea of what those things do. It takes a little practice and work to understand what all that does, but that's a big part of troubleshooting and installation. You can see very quickly by looking at that exactly every single thing that is occurring as the computer boots. And so if there are problems, if there are misconfigurations, if there are things you've done wrong, sometimes they're a little hard to spot, but you can find them, spot them, and fix them, which is super powerful. Just a quick thing about processes. We'll talk a lot more about processes. But once a kernel is loaded, the kernel loads the processes, right? Processes are everything that's actually occurring. So if I print, that's a process. If I'm displaying things on screen, that's a process. If I'm web surfing, those are processes that are occurring. The big process is this init process, right? Init is process 1, PID, process ID. Yeah, process ID. 0, which is init, that's like the grandparent, whatever, of all of other processes. In other words, init starts, and then after init, everything else is managed through init. So that's your PID 0 in all cases. Again, not too deep into this. I realize for some of you that may have been frustratingly simple. There are a lot of questions that can come up. Feel free to reach out and continue this discussion. Certainly it is important information. What you're going to see from respects of this class and what you need to know is going to be more about what I've just discussed. Not actually implementing, but what is a master bootloader, what is a process, what's the first process that runs when the kernel is going. Those kinds of things are what you should expect to see.